So those that did not fall between the higher and the lower bound, you take them away. But this time around, we are seeing how to take out the outliners using the Z-score. And Z-score is gotten from the SciPy, which is scientific Python package, just like NumPy. From the SciPy, you import the stats, and you'll be able to get that. Now we'll see, and we can see the outliners. Then what we do is to take them away. You take the outliners away. Okay, so good and perfect. Then presented is the new data frame without outliners. So now you have to scale. Remember, you have to perform your scaling. Your scaling is all about your standardization to ensure, the normalization of your values to ensure that they are in a normal range. So you can either use your standard scaler or your min-max scaler, that nothing falls above the normal value. Okay, so this is your scaling. Done scaling. What you have to do next is to check for your test score, to get your test score using, excuse me. So you proceed in the model building. This is where you want to split the model to validate, split it to what is it called? You are splitting to train and test. Then you will use your CV, your cross validation, to validate your model. Okay, so after performing this code, remember I told you this material is gotten from our mentor, Global AI Hub. So we are just explaining to those that are not privileged to learn from Global AI Hub. So this is an extension of the knowledge we've gotten from Global AI Hub. All credit goes to Global AI Hub and also to DSN, Data Scientist Network, and also to What Wants University. Thank you. Okay, the cell is still running. It's still running. Remember, whenever you are using your logistic regression, it is advisable you set the random states. Why should you set the random state? You are setting the random state so that when you run that regression again, it will give you same value. You know, it is a random process. So if you do not set a random state, that's something like a seed. If you do not set the seed, anytime you come to the notebook to execute the model, it gives you a new value. Good. Then the end job tells you the number of times you should do the job. When you have end job equals to -1, it's simply telling me that as many times as possible, do this regression, do this classification for me, do this classification for me, and ensure that it comes out better. So it has done it, and you see that the accuracy is what, 95%. The training accuracy is 95%, but the test accuracy is 96%. Is the model doing good? Is the model doing good? Okay, we can see this. This is to get our confusion metrics, and we are using Matplotlib as a visualization tool, and Seaborn also for visualization. Now you see what our model performs. From this, you can see that our model, it rightly predicted that 51 people don't have cancer, and that is correct. But it wrongly predicted that 5 persons don't have cancer and they have cancer. This other true positive. This is true positive. False positive, sorry. This false positive, it tells you that 0% does not have cancer, and that is true. And the true positive, it tells you that 93 people have cancer, and that is true. They actually have cancer. Okay, now when you evaluate this, you find out that it gives you the training and the test accuracy very well. It gives you the training and the test accuracy. Now you have to observe something, that look at this process. Now we have what? A test accuracy has been increased to 97%. Now what made the test accuracy to be increased? Look at this first part of training. Look at this first part of training. And look at the second part of training. What can you see is the difference that made the accuracy to increase? That made the accuracy to increase. Comment it, and there will be an award to those that got it correctly. Okay, now this is just an explanation of the confusion matrix. The first cell is true positive, where you have positive, which is at the bottom, and you have negative, true negative, where you have 0 is true negative. Then when you have 1 or 10 is true negative, and this when you have 0 is true negative. Okay, so this is just showing you the way you can calculate your confusion matrix. Even from the confusion matrix, you'll be able to perform your accuracy. You'll be able to test by yourself very well. Okay, to get your accuracy, your precision, your sensitivity, and the recall and everything, you'll be able to do that very well. Okay, now look at this. Is the classification report. If you want to get everything at a go, you use your classification report. It gives you your recall, it gives you your accuracy, your precision. Most of the times it's not just based on accuracy. You look at your recall and your precision. Precision is actually the number of precision, is the number of those ones they say they are positive and they are really positive. That's precision. Good. Then okay, we'll proceed. Now we want to see a way to get our metrics from our model, even without going through the process of classification report. Now this is just an example how you can get those things. You see, you can get your accuracy when you use accuracy score. You pick in your test and you pick in your predicted the predicted values, the values for prediction. You fill it in, it will give you the accuracy report. Okay, now there are different metrics. Now, like I'm saying that most of the times it's not just all about accuracy, but you need to look at the precision and you need to look at the recall. When should you use your accuracy? When there are roughly equal number of sampling belonging to each class. When you find out that there's a kind of a balanced sampling, a balance between the two classes, you use the accuracy. Now, when should you use your precision? Precision is a good measure to determine when the cost of false positive is high. Now, if you are in a situation like a very good one is in a health situation, and you have to build a model that whenever that will determine the sugar level of a patient, and if that model have a high number of false positive, it is not a good model, even if the accuracy is high. If the false positive is high, it's not a good model, because once it tells you that yes, this person's sugar level is high, and after the person's sugar level is not high, it will have a devastating effect by you, the doctor, going to inject the person some insulin, which will affect the head. So when false positive, the cause is high, that you predict something that it is true and it is not true. When the effect is high, please, you have to ensure that you look at your precision. So to bring down that high positive, that you have a very good precision rate. Okay, so for instance, image span detection. In image span detection, a false positive means that an image that is not a span is sent to a span, and you know what that means, you know what that costs. It will cost a lot. So in short, in such a model, you ensure that you have a very good precision. You concentrate on the precision and not on the accuracy. Now, when should you use a record? For instance, in fraud detection or a sick patient detection, if a fraudulent transaction is actually classified as positive, as not fraudulent, there is a problem. So you should use a record. It's a record. So by the time you see a true positive or an after positive as a false positive or as a false positive, then there's a problem, because when I have when there's a fraudulent transaction, it will say it's not a fraudulent transaction. Then all the non-fraudulent transactions, it will not be holding them as fraudulent transaction. Okay, when should you use your F1 score? F1 score might be a better measure to use if we need to seek a balance between precision and record, and there is an uneven class distribution. So when the class does not have equal distribution, you use your F1 score. And there's another, which is area under the curve, AUC or ROC. When you use this, it's a performance measure for classification problems at various threshold settings. ROC is a portability curve, and AUC represents degree or measure of. So the accuracy that better fits you, that is what you should use. Okay, here is here are code to plot the curve for our model, and you see how the model performs. So this is the conclusion for yesterday, which is day 3. A conclusion for yesterday, which is day 3. So briefly, we take a little break and go into the conclusion and go into what we have for you in day 4. Thank you. Okay, welcome back. We are starting day 4. Yesterday being day 3, we did conclusion on logistic regression using the data sets from scikit-learn, and also using just a little data set. But today we will build a logistic regression model, and also we will diversify by using a decision tree model and also some other model based on this data set we have today. The data set is social network advert, and this data set is gotten from data scientist network, or which was formerly known as data science Nigeria. So all kudos goes to them, and we'll start right away. So the first thing is to import the libraries. We'll see NumPy will be imported as NP, matplotlib.pyplot will be imported as PL3, then pandas will be imported as PV. These are the default primary libraries that you use. They are essentially for data science, because from data science you go into machine learning. So they are essentially for data science. Now what is happening here is we are importing our data sets. And we also perform what is called our splitting. We are splitting the data set. Before we proceed, let's see the data sets. Let's see so I can explain the code better for you. Okay, so we'll see our data sets. We have our data set. We'll see that, and you see the data set. The first code, what it takes as n is that ilog is index location. It takes everything in the row. And what we need in the column is the second and third. This is 0, 1, 2, 3. So this is 2 and 3 that we need. 2 and 3. We need the values. So it picks this index and pick 1. That does it. Okay. Alternative way of performing this action is simply by saying data sets of what? Of age and estimated salary. Age, estimated salary. So it will give us estimated salary. So most of the times you put this in double brackets to be on the server side. You perform this. You see, that is what this value will also give us. Remember I said this will give us this. Okay, I do this. See, so it picks out the values. What are those are the values? Now if I remove this dot value, it gives me that same stuff. So because I put dot values, it picks out just the values. It picks out just the values. And that's what we have there. Okay, so we can proceed our goals. After performing that, the next step, we've done our vertical splitting which is X and Y. Now the next step is to perform our horizontal splitting, which is using train test splits. So we have to import the train test splits from scikit-learn. So we'll perform this importation. After importing the train test splits, apologies. I just have to pick a code. Dot model selection, please. So this is done. We import the train test list. Okay. Now from this train test list, we can take we can see the size of our train and size of our test. Remember, this code here is just actually telling it use 25% as the test size, then use 75% as the train size. So we can perform a simple stuff, length of X train. It gives us this 300. Good. So and we can also see plus length of Y, or let's say X test. X test. It is to give us 400, which is this value. So this is actually the splitting. So we have to perform our scaling. This process is very important, that we have to scale. We have to scale to ensure that our values are not out of the norm. They are not out of the norm. Okay, after scaling, what next you have to perform? You have to perform what? Your logistic regression. First and foremost, you have to import logistic regression from linear regression from linear model. Yes, it is called logistic regression, but it's actually a classification problem. So, like if you see from the data set, it will classify if it's in a class of 0 or if in a class of 1. Which means if it is 0, the person did not purchase, but if it's 1, the person actually purchased from that particular advert that was done. Okay, so this is the set to say, okay, use the set random set of 0, because we want it that whenever it is done, it will reproduce the same result. Okay, this our model has been initialized and it has been fitted. This has initialized and it has been fitted. Okay, here is this line. We are predicting the test results. We are predicting the test, and if you should print it out, you see that this white thread has actually been predicted. Let's see. Let me just print the first 10. You see this? This is the prediction. And if you should look at your X text, let's look at the X text. Look at the X text, and I'm looking at the first 10. I'm looking at the first 10 also. Then you see this is the X test. You now find out that this is class 0, this is class 1. That is what we have here. This first column is class 0 and this is class 1. Now it looks at it. The probability for it to be in class 0 is higher than the probability of being in class 1. Therefore, it costs you 0. Look at this again. Its probability, this should be in the probability of it being in class 1, that is class 0, is higher. Remember, this is negative. It's higher. So it takes this. So that's what it does, and goes through. It goes through and pick the right classes. Now looking at this cell beneath is for the confusion matrix, to draw the confusion matrix. Now you can see to give you the confusion matrix, you have not done the visualization, you just use scikit-learn to get it. And if you can find out that from this confusion matrix we have these values, now let's see the visualization so we can explain it better. Okay, sorry, we are visualizing let me visualize the confusion matrix so we can have it better. Imports. Yeah, let me get the exact code. No. Let me box bro. Let me just go through this code. Aha, thank you. Just hit map. It's hit map actually. CN. So this shows us what you want. If you want to perform other stuff, you can so I can get those values inside. You see this? So this is actually 0 0. Is 0 0, and this is 1 1. This is the number of true positive, and this is the number of true negative. So this model actually is predicting true negative, false positive, and false negative. So it's predicting 3 and 8 wrongly. Okay. When you see this, you find out. Look at this: 1, 2, 3, 4, 5, 6, 7. These are the wrong classes. So this is the visualization. If we see the accuracy, if you want to see the accuracy for this from our model, you can easily do this. This classifier. Sorry, I changed it to Markdown, that's why. Classifier dots I use the score, and we'll fit in our y train y test, sorry, x train x test, x train y train. So this is the training accuracy. The training accuracy, then the test accuracy, you get that dot score x test, comma y test. So this is the accuracy of our model, how well our model is predicting, how well it is predicting. Okay, so this is for logistic regression. It's for logistic regression. Remember, I told you logistic regression is actually a classification algorithm. It's a classification algorithm. Now we are going to make use of decision tree. We're going to make use of decision tree to see the performance of the model we built so far. So make use of decision tree, not decision tree regressor is for a regression problem, just as we have the class B, logistic regression. Then for you have the linear regression. Sorry. Then decision tree classifier is a classification problem, just as you have in the case of what is it called? In the case of a logistic regression. So please don't mix it up. Don't mix it up. So in this particular place, in this particular code, we'll try to make use of decision tree make use of this so all I have to do is from sklearn import this. So for it to be passed from sklearn import decision tree classifier. Then this is for classification place, decision tree classifier. Good. So this is my train and my test. Then okay. So I can have my DT as the variable I gave it, dot score x test, comma y test. And see, this is actually performing higher. It's actually performing higher than our what is it called? Than our classic logistic regression. We have a higher performance. Look at this. Look at this. You see that it has a higher performance. There in line 21, this is for the classifier, but when logistic classifier. But when we use decision tree classifier, we have accuracy of 90%. We have accuracy of 90%. One more model I will show you how to use is what the support vector machine. The support vector machine also have support vector machine regressor and support vector machine classifier. So all I have to do is from sklearn dot support vector machine import support vector import SVC is classifier. But if it's a regression problem, I can import the regression. I can import the regression aspect of what's it called, of support vector machine. So haven't done that. I have this RVC. So I'll perform my train and my test. Then I do this. Then let me get my score. I can say SV this dot score. That's the way you can use the score method to get your accuracy. Actually, I'll fit in my train and my test. My two tests. Then I drop it. You see, the support vector machine performs better. So we can see from these three classifiers we built today that the support vector machine with respect to the data set performs better than the other two classifiers. And this will always produce a better result. It will always produce a better result. So once more, before we call it the end for today's training, we've seen that we use our data sets to build a logistic regression, which is a classifier. We use it to build another classifier model, which is a decision tree classifier, and we also use it to build another classifier, which is support vector machine classifier. So from these three, we found out that by default, because we did not do any parameter hypertuning, by default, the support vector machine classifier performs better. Now, just the way we change this, you can also perform the same. Looking at your code, looking at this code in the tree, okay, sorry, it's in the 4. Before looking at this code, in the to improve, you can also perform the other aspect of regression. Remember, this is what our mean square gave us for our regression model. So briefly, we can okay, I am taking you backward. So it will be that we created views both linear regression and logistic regression. We've used support vector machine classifier. We've used support vector, we've used decision tree classifier. Now I want to make use of decision tree regressor and support vector machine regressor. So in the aspect of decision tree regressor, I just have to perform this. Because of time, I'm taking code I've already written down. We see this. So I have my train and my tests. Good. So this is just all I need to do then I run this code. It will from sklen.tree, it gives me this. Remember, this is what my value gave me. I mean assault square error. Okay, now I perform send from this, and let's see what it will give me. And it gave me this. So in the decision, in the linear problem, the linear model we built, we find out that our model that was built using decision tree regressor performed better. So in either cases, you just test and see which of your model performs better, which of the algorithm you want to use that will perform better. Then whatever that performs better, you make use of it. So far we've seen the algorithms, we've seen decision tree classifier, we've seen decision tree regressor, we've seen support vector machine classifier, we've seen support vector machine regressor, we've also seen linear logistic regression, and we've seen linear regression. So far, we've looked at 6 different algorithms, and we've built more than 6 different models. So tomorrow we'll be building a random forest model. We'll be building a model. Sorry, permit me before I say a forest. We're building a model which is based on random forest, and I'll try to explain the concept of random forest. Then that will terminate the class. So once more, if you need the files that we've used so far, you can comment in the comment section that yes, you need it, and you drop your email address. We'll send it directly to you. Once more, our appreciation goes to Global AI Hub and Data Scientist Network, formerly known as Data Science Nigeria. But we use their materials, we use their resources for this workshop. Is an extension of not free workshop, and we appreciate them, and a very